Okay, this is a demonstration of the UVX 300G-FGC. The UVX 300G-FGC has a display of relative signal intensity on a scale of 0 to 99. And also has three different LED intensity settings. Right now we're at the highest setting, and we are probably about 100 to 120 millimeters from the sensor to the target. So we have, right now we're testing an invisible UV fluorescent yellow-green material, ink, and on a fabric. So the sample fabric was provided by the ink manufacturer, and we placed a sample onto a white business card. So there's the white business card background white, which is reading about 34, and then the yellow-green pigment reads up about 60. So we're going to look at the fabric. The red LED is an indication that the signal is high enough that it has gone over the threshold. So right now we have the signal threshold set at a value of 40. That's connected to a discrete output that would indicate to a PLC the presence of the invisible UV ink. So again, the background of the fabric, we're reading around 23, and when we go on to the area of the fabric where we've placed some of the UV ink, we're reading about 75. You see the output triggers when we go on to the area where we've coated it with the ink. So that seems to work fairly well. This is the UVX 300G-FGC has a built-in filter that suppresses much of the signal from the bright optical brighteners in the fabric. So even though we would otherwise have a very strong signal from the fabric, it's suppressing the blue and allowing much of the yellow-green wavelengths to be measured. So we're getting a strong enough signal to be able to detect the ink on the fabric. We also have a sample of red fluorescent ink, and what we have found with red pigments in the past is that they have a relatively slow decay rate. Therefore, the modulation frequency of any of these types of sensors cause it to be difficult sometimes to read the fluorescent material. It's actually a phosphorescent material, since it continues to emit light shortly after the UV light source has been turned off. So for the moment, we do have a model of the sensor that has been modified to read red pigments. However, that sensor is also, because it has been modified to allow it to read over much longer periods of time in order to capture the signal from the slowly decaying red pigment, it also is susceptible to interference from external light. So the special version of the sensor to read the red pigments would require use in very tightly controlled, low ambient environments. So for the moment, for now, I would suggest that the fluorescent yellow pigment material ink would work well with this application. I don't think that the red will be much stronger, probably not any stronger than the yellow-green. So we're producing a relatively good margin here between the 25 or so, 24, 25 on the white, and the around 70 on the area where we've placed the yellow-green pigment. So that's the UVX 300G-FGC.